Okay, so uh, now we shall explain some various properties of conditional probability. Properties of conditional probability. So the first property is the probability of the sample space given any event f, that is equals to probability of f given f, that is equals to 1. Here S is what? S is the sample space. Means it is the set of all the outcomes, set of all possible outcomes of the random experiment, set of all the possible outcomes of the random experiment. And F is any event, and F should be a subset of the sample space. So this can be proved in this way, that probability of the sample space given F, mm, that is equals to probability of S intersection F divided by probability of F. So now since F is a subset of S, so S intersection F will be F only. So it will be probability of F divided by probability of F, which will be equal to 1. So probability of F by F, that can be also written as probability of F by F given F. Since why, it will be probability of F intersection F divided by probability of F. So probability of F intersection F is nothing but P of F divided by probability of F, which is also equal to 1. Hence, these two are equal, which is equal to 1. Then the second property is, if A and B are any two events, which are associated with the sample space S of a given experiment, associated with the sample space S of a given random experiment. Um, and F is also another event. F is also another event of the sample space S of the sample space S. Then we can say that the probability of the event A intersection, sorry, the probability of the event A union B given F, that is equals to the probability of A given F plus the probability of B given F minus the probability of the event A intersection B given F. And this will be true only if and only if the probability of the event F is not equal to 0. So here uh, so we can say that if the events A and B are disjoint sets, it means they are disjoint events, then A intersection B, the set A intersection B will be phi only. It will be an empty set. Empty set. Then we can say that the probability of A union B given F, that will be equal to probability of A given F plus probability of B given F. Since why? Since the probability of A intersection B will be 0 only. That is why. So since the probability of A intersection B is 0, so we can also say that the probability of A intersection B given F, that will be also 0. Since why? A and B are disjoint sets. Okay. Then the next property is property 3, is that the probability of the event E dash means it is the complement of the event E given F, that is equals to 1 minus the probability of the event E given F. Uh, uh, E dash is the complement of the event E. It means E dash means it is not event E. It means E dash, I can also say it is the sample space minus the event E. So now, how to prove it? We know that the probability of the sample space given F, that is equals to 1. So now event E dash union E, that is equals to S. So the probability of E union E dash given F, that is also equal to 1. So therefore I can say now probability of E union E dash, that can be written as the probability of E given F plus the probability of E dash given F minus the probability of E intersection E dash given F equals to 1. So now, since E and E dash are obviously disjoint sets, they are disjoint sets, or I can say they are disjoint events. So the probability of E intersection E dash given F, that will be equal to 0. So this will become 0 only. So therefore we will get P of E given E dash given F, that is equals to 1 minus P of E given F. Hence proved. So we can explain this by using some examples. One example we can take up, that is, suppose we have got 10 cards. Suppose we have got 10 cards which are being numbered like this: 1, 2, 3 till 10. It is being numbered, and they are placed in some box. They are placed in some box. Placed in a box, and then they are mixed, and then one card is drawn at random. One card is being drawn from the box at random. Then if it is known that the number on the drawn card is more than 3, then what is the probability that it is an even number? So it is given that if it is given that the card drawn, if it is given that the card drawn is greater than 3, okay, the card drawn is greater than 3, then what is the probability that it is an even number? So we have to find what is the probability of drawing an even number card given that the card drawn is more than 3. Card drawn is more than 3. So this we have to find. So let's say we tell the event A, it is that the event A is defined as the card drawn is an even number. The card is an even number. So then we can write it as, so the elements of this set will be 2, 4, 6, 8, 10, obviously. And the event B, that is defined as the card drawn is greater than 3. So that will contain 4, 5, 6, 7, 8, 9, and 10. So here we need to find what is the probability of the event A given that B has already happened. It means we have to find P of A given B. That we have to find. So for that, we need to find the probability of A intersection B by the probability of B. So from here, we can find out the set which is A intersection B. It means we need to find the common elements which are in these two sets. So that will be, one is 4, and one is 6, and one is 8, and one is 10. 4, 6, 8, and 10. So therefore, the probability of the event A, that is obviously 5. Simply we have to find how the number of the elements in the set A divided by the number of elements in the whole sample space. So now the sample space is the set of all the outcomes, which means it is 1, 2, 3, 4 till 10. The whole sample space, it is this for this random experiment. This is the sample space for this random experiment. So it will be n of A by n of S. S means the number of elements in the set A divided by the number of elements in the set S. So that will be 5 divided by 10. So that will be 1 by 2. Then we have to find out the probability of the event B. So that will be number of elements in the set B divided by number of elements in the set S. So that will be 4 to 10. So that is 7. 7 elements divided by 10. So that is 7 by 10. So it is 0.7 we can write. This is 0.5 we can write. And the probability of A intersection B, that is obviously the number of elements in the set A intersection B divided by the number of elements in the set S. So that will be 4 by 10, obviously. So that is 0.4. So therefore, the value of this P of A given B, that will be 0.4 divided by 0.7. So the answer is 4 by 7. So this is the value of the conditional probability. This is the one example of conditional probability where we have to find the probability that the event A has happened given that B has happened. It means we have to find the probability of happening of the event A given that B has already happened. Thank you.